Hey designers, this is how you set up an assembly. So here I have my assembly file of my vent mockup that I've been showing you guys in class. And I have some mates for the components that allow me to move certain components. So I can have the cover swivel up to reveal the vent opening. Um, I've got a tab here that I can demonstrate sliding up and down. So its actual travel would be relatively short here. And I have some screws that I've brought in from um, an online source. So I'll tell you about how I set this up. I'll go ahead and I'll delete these components and re-import them so you guys can see that process. So I have my wall cutout. This is my first part that I brought in my previous video. So I just hit check mark on the locate feature, which allows it to snap to the existing origin. So I haven't done any kind of mates with this one or locating. I just brought it in using insert components and I hit check mark and it brought it to my default origin. If I turn my planes on, you can see that everything's lined up around that central origin. So that is my base part that I'm using. Now I can insert my other components. Using insert components, I can browse on my computer and I can begin to bring in my other parts and just stick them somewhere in my workspace. So there's my cover, there's my lock. What else do I need? I need a base plate. And I need a screw. So I showed in class that you can go to McMaster-Carr. It's a provider, a vendor of any kind of building component you can imagine. And they have a library of screws. They also, on the product detail, give you an opportunity to download for a specific CAD package, for example, SolidWorks. So you can go online, you can search for the type of screw that you want to bring in, and integrate it into your model. So I have selected a screw, which I have here, which is a wood screw meant for particle board, which is going to be perfect for us. If we take a look at that screw, it is a button head screw, meaning it's got a round top, it's got a point, and it's got a relatively coarse thread, which is going to be good for holding into low density material like our particle board. So good screw, it's 1 inch in length. You guys can go and find the same one if you want, but I would also encourage you to look around the website. So McMaster-Carr, and you can download the CAD for the part. So I've got those 4 things in here. Let's go ahead and mate them. So mating is how you basically locate a part in your CAD file and make it dynamic. So you can select edges, faces, vertices, axes, whatever is most appropriate for your object. So I'll show you how I place these, and I'll do them one at a time. So starting with my planes, I'm going to mate and going to pick my um, right plane or middle plane. You know, your part might be set up differently than mine, to basically snap this to the center. So I want that to be in the middle. I'm going to turn my planes off momentarily because I want to select this face on, um, oops, I've got the wrong part. So I'm going to leave that for now because I'll do my cover later. I want to get my base plate in first. So I'll turn my planes back on, mate, same thing, right plane to the right plane, turn my planes off, and do a face mate. So I'm going to select this back edge to the front of my wall. That will make a coincident mate, meaning that they are aligned. And now I'm fixed in 2 dimensions. I got to fix my last dimension. So I turn my planes on again. I pick my middle plane for my base plate, and I'm going to snap that to the middle plane there. So now that component should be fixed. In my tree base plate, that check mark or that minus sign, that goes away because that shows that this part is fully constrained. All of these other ones with the minus point mean that I can move them around. They are not fully constrained. So I can grab them and I can move them in the degrees of freedom in which they are not constrained. So I've already done the midplane for that one. I can go ahead and I can select my axes. Now, these parts were created in the same master file. I showed this in the other video. And I brought in the axes for these derived parts, which means they should share the same axis. So I can mate those axes. And now I have a cover that should be able to hinge, meaning rotate on that axis. And that does that. Great. All right, I can do my lock now. Mate. Again, I can turn on my planes. I'm also going to take that mid-plane and mate it. Turn my planes off. And now I can use a face mate again to set up the sliding motion. So I want this to slide on the back surface of my base plate. So I can select the front of my sliding lock and the back of my base plate. And that will allow me to slide it up and down. Nice. So that's well positioned. So I got all those in there. Let me show you the screws. The screws will be a little bit different. We're going to use a concentric mate. So for concentric, you need circular surfaces. So I'm going to pick the outside of the screw and I'm going to pick the inside barrel surface of my hole. This is pointing the wrong direction, so I can flip my mate alignment to point in. I hit check mark. Now, this is concentrically constrained. This is just like the axis mate, but I don't have an axis for this. I don't have an axis for this, so I can use these round surfaces instead. Now I can pull this out and I can mate that surface to this surface. Boom. Now, because I have equal spacing here and it's symmetric, I don't have to do this 8 times. So let me get out of mating there and let me highlight that component and I'm going to do a linear pattern. What that does is it allows me to set up a grid with which I can copy that component. So first direction, I want to go that way and I want 4 instances. I want it to go that direction. And I know from already doing this that the distance is 3 inches that I've used on my master file. So that's the first row. I now want it to go up in that direction. So I want 2 rows, and the distance here is 5 1/4. Preview looks good, and I hit check. All right. So there we go. I've got screws, I've got my sliding lock mocked up here, and I've got my rotating cover. Now, why is this useful? We can use this to check for interferences. We can also mock up the motion that the product will do for us to get an understanding of the user experience. We can begin to test use cases in our mind as we're doing the design, and it allows us to simulate that. What it also does is SolidWorks and working with CAD, it makes assembling parts much easier than in KeyShot that, let's say, KeyShot just uses positional coordinates. So it takes a long time to get something perfectly aligned in KeyShot if you're importing it without these mate assignments. So I can assemble something in SolidWorks, bring it in KeyShot, and then everything is aligned. I'll have to set up this hinge again in KeyShot. It's a separate process, which is a little bit different, but I'll talk about that next week when we get into class. I think it's valuable for you guys to learn to work with assemblies and to be able to basically simulate and role play with your parts as they are coming to life. So hope you enjoyed this video. I'll see you in class.